using Hibernate search as query engine in Hibernate. Now we are considering using Hibernate search as a query engine. Grayed areas are blocks already present in Hibernate OGM architecture. Since Hibernate OGM, how is data queried? Since Hibernate OGM wants to offer all of JPA, it needs support for JPQL queries. Hibernate OGM passes the JPQL query string and extract its meaning. From there, several options are available depending on the capabilities of the NoSQL data store you target. It directly delegates the native query generation to the data store specific query translator implementation. It uses Hibernate search as a query engine to execute the query. If no SQL data store has, if the NoSQL data store has some query capabilities, and if JPQL query is simple enough to be executed by the data store, then JPQL parser directly pushes the query generation to the NoSQL specific query translator. The query returns the list of matching entity columns and projections, and Hibernate OGM returns managed entities. Some NoSQL stores has a poor query support or none at all. In this case, Hibernate OGM can use Hibernate search as its indexing and query engine. Hibernate search is able to index and query objects, entities, and run full text queries. It uses well-known Apache Lucene to do this, but adds a few interesting characteristics like clustering support and an object-oriented abstraction, including an object-oriented query DSL. Let's have a look at the architecture of Hibernate OGM when using Hibernate search. In this situation, Hibernate ORM core pushes change events to Hibernate search, which will index entries accordingly and keep the index and the data store sync. The JPQL query parser delegates the query translation to the Hibernate search query translator. And executes the query on top of the Lucene indexes. Indexes can be stored in various fashions: on a file system, the default in Lucene; in InfiniSpam via the InfiniSpam Lucene directory implementation. The index is then distributed across several servers transparently; in NoSQL stores that can natively store Lucene indexes; in NoSQL stores that can be used as overflow to InfiniSpan. In this case, InfiniSpan is used as an intermediary layer to serve the index efficiently but persist the index in another NoSQL store. You can use Hibernate search even if you do plan to use the NoSQL data store query capabilities. Hibernate search offers a few interesting options: clusterability, full text queries, that is Google for your entities; geospatial queries, query faceting, that is dynamic categorization of the query result by price, brand, etc. Here you can see application interacts with JPA or Hibernate native API. Here Hibernate search and index, Hibernate search indexing engine and query engine and other components are inside Hibernate OGM. Here JPA or Hibernate native APIs interacts with Hibernate ORM core. Hibernate ORM core delegate persistence load queries to Hibernate OGM core. Hibernate OGM core delegates queries to JPQL parser. JPQL parser delegates simple queries to Hibernate search query engine. The JPQL parser and Hibernate search query engine are inside query engine. Hibernate search query engine reads Lucene indexes. Here Hibernate ORM core sends entity change event to Hibernate search indexing engine. Application is connected to Hibernate search indexing engine. Hibernate search indexing engine writes Lucene indexes. Lucene indexes optionally store in NoSQL data store. Now this is the end of my presentation. Thank you very much for watching it.